Hi all. In the last few lectures, we discussed about the amplifiers with a negative feedback, and we have discussed about the advantages of employing a negative feedback in an amplifier. While discussing the negative feedback amplifiers, we mentioned another type of feedback that is called the positive feedback can also be used in certain circuit. The example of circuit which uses the positive feedback is the oscillator, and in this lecture we will discuss about the oscillators, and in the next upcoming lectures we will discuss about the different type of oscillatory circuits and different types of transistor oscillators. As you know, there are many electronic devices require a source of energy at a specific frequency, which may range from few hertz to several megahertz, and this is achieved by an electronic device called the oscillator. So we are going to discuss about the oscillator. So oscillator, we can define it as an electronic device that converts a DC signal into a C signal of desired frequency. The signal frequency of the signal, AC signal, so generated actually depends upon the circuit parameters. This AC signal may be of, we can classify into two categories: sinusoidal oscillators and non-sinusoidal oscillators. Sinusoidal means the output waveform of this circuit resembles that of a sine wave, and the other type is the non-sinusoidal oscillator. Non-sinusoidal oscillator means that the output waveform of the oscillator is non-sinusoidal. That means a square wave, it may be a square wave, it may be a triangular wave, it may be a sawtooth wave, and so on. So the multivibrators are examples for oscillators which produces the square wave output. The sawtooth generator produces a sawtooth wave, the triangular wave generator produces a triangular wave, and so on. So here in this course of lectures we will discuss only about the sinusoidal oscillators. That is, the output waveform of the oscillatory circuit is a sine wave. So sinusoidal oscillators can also be defined as the electronic device that generates sinusoidal oscillations of desired frequency. This desired means this is actually the designed by the observer who designs this circuit. This oscillator actually different from the other type of sinusoidal wave generator. We call it as the alternators, because we know that alternators also produces a AC signal with a frequency in approximately 50 Hz. But the alternators cannot be treated as an oscillator, because oscillator can be designed to generate a frequency range from few hertz to several megahertz. So the range of frequency that an oscillator produces is from few hertz to several megahertz, but the frequency produced by an alternator is very low. It is usually around 50 hertz, and there are also many differences between an oscillator and an alternator. So if we consider an alternator and oscillator, there are many advantages of oscillators over the alternators. So let's just mention those advantages of oscillators over the alternators, because you know that alternator is actually having a moving or rotating parts, but an oscillator does not have a rotating part. So since the oscillator is not having a rotating part, or it is a non-rotating device, Consequently, there will be little wear and tear occurs for an oscillator, so it will have a longer life. So one of the advantage of oscillator over the alternator is that it is having a longer life because of little wear and tear occurs in the oscillatory circuit, since it does not have any rotating parts. Another one is that since the oscillator is not having any moving parts, the operation is silent, but alternator is having a moving parts. So when we are comparing with alternators with oscillator, the operation of the oscillator is silent. And I told you already that oscillators produces waves from very small or few hertz, that is from around 20 hertz, to extremely high frequencies, that is greater than 100 megahertz frequencies. Another advantage of oscillator over the alternator is that the frequency of oscillation can be changed when desired. That is, the frequency of oscillations is determined by the parameters of the oscillatory circuit. So by changing the parameters of the oscillatory circuit, we can change the frequency of oscillations of an oscillator. So that is another very important advantage of oscillators over the alternators. The frequency of oscillation can easily be changed when desired. And another thing is that it provides good frequency stability. That means the frequency once set remains constant for a considerable period of time. In the case of an oscillator, the frequency stability is very good. That means once an oscillator is designed for a particular frequency, then the frequency remains constant for a considerable period of time. And the another important thing is that the oscillator is having a very high efficiency. And also one more important thing in the case of an oscillator is that it is very compact in size, and it can be transported from one place to another very easily. So that means it is portable. The alternators are very hard to port. To transfer one place to another, it is very difficult, but in the case of an oscillator circuit, if we consider an oscillator, it is a portable device. So, and it is very small in size also. So these are the advantages of an oscillator over the alternators. The important things are it can produce frequencies from around 20 Hz to greater than 100 megahertz frequency, and it gives a very good frequency stability, and it is very effective when compared to the alternators. Its life is long because it does not have any rotating part. So these are the advantages of an oscillator over the alternator. Now let's consider some of the types of the sinusoidal oscillator. I told you in these lectures we will consider only the sinusoidal oscillators. So these sinusoidal oscillators we can broadly classify into two categories. Since all oscillations, you know that the oscillations may be having a damped oscillations or undamped oscillations. So if we consider sinusoidal oscillation, we can have two types of oscillations which are called damped sinusoidal oscillations and undamped sinusoidal oscillation. You are familiar with the term damped. Damping means the amplitude of the signal goes on decreasing with time. So if the amplitude of the output wave goes on decreasing with time, then it is called a damped sinusoidal oscillator. If you consider this signal, this is the y-axis actually contains the EMF or the current. The EMF here it is represented by E, or the current is represented by I, and x-axis is the time. So if we consider this output waveform, the amplitude is decreasing as time goes and finally it dies off. This type of oscillations are called damped oscillations. The reason for damping in a circuit is that there are some losses occurs in the circuit. Usually in the case of a sinusoidal oscillation, the losses are either usually it consisting of a capacitor and the inductors. Then the capacitors will have dielectric losses, and the inductor will have resistive and radiation losses. So due to these losses, the amplitude of the signal or the output wave is decreasing with time. They are called damped oscillations. So the damping is due to the losses in the circuit. Now if we consider another type of oscillation, that is the undamped oscillations. Undamped means the amplitude remains constant and it does not change with respect to time. So this, if we consider this diagram, you can see that the x-axis is the time and y-axis is the EMF or current, and the output waveform will always have a constant E0 or I0, constant voltage or current. This is minus E0 or minus I0. So the amplitude remains constant with time. Such oscillators are called undamped oscillators. But remember that don't think that this, since the amplitude is constant, don't misunderstand that there are no losses in the circuit. But in the circuit there are losses, but these losses are compensated by some energy providing from the external sources or the circuit itself. So the losses in the circuit are compensated by providing the particular amount of energy to compensate the losses. So in an undamped oscillator, the important thing is that in addition to the oscillatory circuit, there should be some compensating circuit to compensate the losses in the circuit, so that once the losses have been compensated in each cycle, then the output voltage or current remains constant with time. So these are undamped oscillators. Now we have to discuss about how we can produce an oscillation, that is how we can produce AC signal from the DC, or we can say that how we can convert DC energy into AC energy, and that we will discuss in the next lecture. Thank you.